Let's talk about the building blocks of geometry, points, lines, planes, and angles. Start off with a point. A point is just a location. It's infinitely small. It has no size or shape. It's just simply a location. If you get enough points together going infinitely in two directions, in two opposite directions, then what we have is a line. So if you have 2 points that are on the same line, we call those 2 points to be collinear. But a line is made up of an infinite amount of points. Okay, infinite means it goes on forever. Now, if you were to pick 2 points and designate those as endpoints, then that would give you a line segment. Okay, a line segment is where we call them endpoints, but just you pick 2 points and 1 point is the beginning and 1 point is the end. Because segments have beginnings and ends, it is possible to take the distance of a line segment. It is not possible to take the distance of a line. Also, because a line segment has a beginning and an end, it's also possible to find the midpoint of a line segment. We've discussed midpoint previously. Midpoint is the point that is in the middle. A new word that we want to introduce is that a midpoint would bisect the segment or cut it in half into 2 equal parts. These slashes that we see on the segment here in red, those symbols mean that each part that's on the left and right side of the red point are the same in distance, what's called congruent. A ray is kind of like a blend of a segment and a line in that it has one endpoint, but then it goes forever in one direction. So the endpoint we know the name of, but in order to be able to name a ray, you're going to need one extra point, and we'll call that the through point. So the through point is what goes in that direction that we're going on forever. We'll talk about naming a little bit lower in the page. A plane is a flat surface that has an infinite amount of points in all directions, up, down, left, and right. Flat being the key word, but now we're going forever in all directions. If you have 2 points that are on the same plane, we call those coplanar. I like this graphic because it says a lot. So let's look at each column. This is the drawing of a point. Okay, points are labeled with capital letters. It's drawn as a dot. It's named as a capital letter, and a point has neither size or shape, as I stated before. And the way that you would name them is just by putting that capital letter describing point P. Here you have a drawing of a line. Notice how we have 2 points. In order to be a line, you need to have the arrowheads on both ends. Those arrows are what dictate that you go on forever in 2 directions. The way that we name a line is using 2 letters. If you look down here, this line could be named AB or BA as long as you have the symbol on top with the 2 arrows. It's not as common, but also writing the word line in front is another way of naming a line. A plane, here's a drawing of a plane. It's a it's flat, and the way you would name a plane is with a capital script letter. Here, script is kind of like cursive, so in this case, you can name this plane T, as you see down here, or with any 3 points, as long as they're not all collinear. So these are all different ways of naming this plane because X, Y, and Z are not on the same line. The 3 points, any 2 points would be collinear. So, X and Y, you can draw a line through them. Y and Z, you can draw a line through them. X and Z, you can draw a line through them. But since there is no single line that goes through all 3, you can use all 3 of those points to name the plane. Just to give you some more exposure to symbols, This is the way you would name a segment. Here's the in blue, you see the drawing of what a segment would look like. These are ways to name it. Notice what's missing are the arrowheads. And then for a ray, this is the way that you would draw a ray. Up here on the first ray, the end point is A, the through point is B, so you would have to label it this way, AB, with the arrowhead on top of the B. If this were the case and B were the end point, then you would draw the arrowhead over the A. The B would be the end point and the A would be the through point. If two rays had a common endpoint, what they would create would be an angle. Now, angles can also be created with intersecting lines or intersecting segments, but the definition is two rays that share a common endpoint. Those rays we call the sides of the angle, and that common endpoint we call the vertex. So here, the rays AB and AC, those are the sides, and the vertex, the common endpoint, is A. There's various ways to name angles. The most common way to name an angle is by using 3 points where the vertex would have to be in the middle, meaning I could call this angle BAC, or I could go backwards and call it CAB. What you see over here that looks like a slanted L, that's the symbol for angle. Now in this case, if there is only one angle that is coming from a vertex, then you could name the angle just by that vertex, like here where it says angle A, or in some instances angles are labeled by numbers, so you can also name them by the number, but that's not as common. So these are just some different ways that you can name the angle that you see in front of you. Here are some categories of angles, right? We measure angles by using a unit known as degrees, and we'll use a protractor. If an angle is 90 degrees, we refer to it as a right angle. If an angle is less than 90 degrees, it's known as acute. And if it's between 90 and 180, we call it obtuse. In geometry, the word congruent is used basically as a replacement for equal. It means the same thing as equal. So if two angles have the same amount of degrees, in this case, angle NMP and angles QMR are both measuring at 25 degrees, then we can say that those angles are congruent. Notice these arcs here are symbols that show that they're congruent, even if the 25s weren't there. Some books also like to use slashes that would state that the angles are congruent. Finally, you saw this word before, bisector. Just the same way segments can be bisected, angles can be bisected. If you draw a third ray through that common endpoint, and that ray happens to cut an angle in half, then you can call that ray an angle bisector. One last slide dealing with angles. This gives you different categories, different types of angles, and I like to focus here on the non-examples. I think the non-examples are a good way to learn this. So like first we start off with right angles. And if we look at the non-examples, the reason why this 46-degree angle is not right is because, well, it's actually acute. The reason why this 105-degree angle is not right is because it's actually obtuse. You can also take a moment to look at the actual examples of the right angles. Okay. Here with acute angles, if we look at the ones that are not acute, and the reason why, this one's obtuse because it's 100 degrees. This one, even though we don't see a number, the box means it's 90 degrees, so this is right angle. And this is actually also obtuse because it's greater than 90. If we look at the non-examples here for obtuse, this 38-degree angle is considered acute. This one is considered to be right. And this one is also considered to be acute because it's less than 90. complementary angles. Complementary angles are two angles that, if you add their degrees together, they give you a right angle. They give you 90 degrees. So here, the reason why that these are not 40 plus 52 is 92 degrees. That doesn't give you 90. Okay. Here, even though we don't see numbers with angle 3 and angle 4, if we were to add these together, they make a straight line. The straight line is 180 degrees. And for here, with angles 1 and angles 2, even though we don't know an angle measure, if we were to find, if we were to use a protractor and add them together, it looks like combined they would still be less than 90, which make them acute. It wouldn't add up to 90 degrees. Those angle 1 plus angle 2 would be less than 90. One that we use even more often than complementary is supplementary. Okay. In order for angles to be supplementary, it needs to be two angles that add up to 180 degrees. So here, even though angles 1, 2, and 3 do add up to a straight line to 180 degrees, it's not a pair of angles. There's three of them there. And with angles 4 and angle 5, if you were to have a protractor, just like on the previous example, that would actually be greater than 180. It wouldn't add up to 180 degrees. Vertical angles. We'll talk more about vertical angles as we go along, but vertical angles are formed at a single intersection, and they're angles that are across from each other. Vertical angles are said to be congruent. As we go along, we'll see that vertical angles are congruent. If two angles at an intersection are not across from each other, then they're known to be what are called adjacent angles. So if you look here at the example with angle 1 and angle 2, if angle 2 would be here, where I just drew the 1, then they would be vertical, but these two angles are adjacent. Here, the problem with 3 and 4 is that angle 4 and angle 3 are at two different intersections. Angle 4 is up at the top intersection, angle 3 is down at the bottom one. Okay. Here, the problem with 5 and 6 is that these are not two lines that are intersecting. Even though there only is one intersection, these are just made up of 4 separate rays. 7 and 8, same thing. There's one straight line, but then we have these two separate rays that are going in two other different directions. So those can't be vertical. And with 9 and 10, there is no intersection. They don't meet. A linear pair. Okay. All linear pairs are supplementary, but not necessarily all supplementary angles form linear pairs. A linear pair is just a pair of supplementary angles that have a common endpoint. So instead of let's actually focus here on the examples instead of the counter examples. So you could see here, for instance, angle 1 and angle 2. Not only do they add up to 180 degrees, but they also share a common endpoint. Same thing here with the 3 and the 4. If you look at all the non-examples, this is not occurring there. The last thing I wanted to discuss is adjacent angles, which we mentioned up where the vertical angles were. Okay, adjacent angles are angles that are going to be next to each other. So, here angles A, B, C shares a common endpoint, and it's next to angles C, B, D. So those are adjacent angles. Okay, same thing over here, A, B, C, C, B, D. Adjacent just means next to.